My name is Bradley Harz, and me and my mentor Nicole, we did estimating fire radiative energy and comparing it to the rate of spread in major wildfires. So wildfires have been spreading more intensely and faster in recent years due to various reasons like climate change and drier weather, and also due to irresponsible camping and the way that we've maintained forest until recent years. Connecting with tribes, we've learned to do prescribed burns a lot more and pick up debris a lot more. I focused on how does fire radiative energy released by a fire compare to its rate of speed. Here are some key terms I'd like to go over because a lot of these acronyms are a little weird. VIIRS is the Visible Infrared Imaging Radiometer Suite. It's a device on the NASA NOAA satellites that images the hot spots and measures the instantaneous fire radiative power. The MTBS is monitoring trend in burn severity, and this is a device used by the USFS and USGS to look at to produce annual burn severity maps and fire perimeter shapefiles. And FRP is a fire radiative power. That is the incremental radiative power released at a given moment. And FRE is calculated from that, and that is the cumulative fire energy released over time. ROS is rate of speed, the speed of the fire expansion in acres per day. And DNBR is difference normalized burn ratio, and that's the burn severity indexed by near infrared to shortwave infrared. I didn't put IC. What happened? I'll just say this while this is going. I didn't put it on there, but there's also the ICS 209 plus, and that's the incident command system, 209 form, and that is to look at the near real-time fire perimeters, the burned acreage, and the narrative updates. Thank you. So I went over 7 different fires. I mostly looked at these ones. These were the main ones I looked at. These are all Colorado fires in 2020. They were right around Estes Park. East Troublesome is the second biggest fire in Colorado history. It's the biggest fire in Colorado history. It's the second biggest fire on the ICS 209 data set. Sorry about that. And these are all in Colorado. And then these were, let me see here real quick. Watson Creek was in Washington. Caldwell was in California. Ginny's Peak was in California. And Chetco Bar was in Oregon. The VIIRS FRP is 500 meter resolution, and it goes by twice daily to look at the fire radiative power. ICS 209 plus looks at the daily acreage burned within the set perimeter, and the MTBS are the final perimeters for cross-checking between fires. I retrieved the VIIRS FRP scans over each incident for its active period. I integrated the FRP over time, 12-hour composition or composites. I used the trapezoid rule, the Simpson rule, and the midpoint rule to find all of this. I compared the integrators, and I found out that the trapezoid rule was fairly comparable to the midpoint rule. They had within or less than 4% difference. I decided to choose the trapezoid rule for my project. I I'm unsure about the Simpson rule at the time. I might have done the coding wrong because it should have had closer to that range, but I still put it on here just to show. And then with the rate of spread calculations, I extracted daily fire perimeters from the ICS 209 plus data set, and then I computed new area burned between successive perimeters and looked at the change of area over the change of day. Some of the caveats of this are the irregular update intervals within the ICS 209 dataset. It seemed best to calculate per day average or per day at largest peak growth. We decided to go with calculating per day at largest peak growth to see the instantaneous spread at the most extreme time. We would like to have some perimeter smoothing by different teams that could help later on. Oh yeah, okay, never mind. I'll talk about that in a second. We hypothesized that there would be a strong correlation of 0.85 regression, but the data was limited. We only used 7 fires, which just isn't enough data to actually have conclusive evidence of anything. Our Pearson's R turned out to be 0.171 with a linear regression of R squared 0.29. This should have gone up a little bit more from what I've seen from other research. And most clusters were along the 1-1 line, but the Watson Creek and the East Troublesome were kind of far out here, and they might have skewed the data with the limited data set at least. And then, as I said, the outliers were East Troublesome and Watson Creek, with East Troublesome having a very high rate of speed, but a lower fire radiative energy, and Watson Creek having a very high fire radiative energy, but lower rate of spread, which was really interesting. Some of the possible explanations for this are the Veers FRP could have had underestimations due to dense smoke or nighttime and missing peaks due to that. Also some perimeter reporting lags and less biomass or fuel in a given area, causing less FRE. Possible explanations for Watson Creek could be the Veers ICS 209 time gaps, and the FRE captures peaks during times Ross, or could capture peaks during times Ross underreported acreage per day. There could also be a small area with heavy fuel for intense burn but less spread, and could have steep patchy terrain and high energy and slow advance. I'd have to do some field research to see how that looks. I used a small sample size of only 7 fires. I will have to look at the broader fire behaviors to get, like I said, to get valid data. The Veers, and another limitation was the Veers temporal gaps, which could have missed short-lived peaks. Some next steps are to expand from 10 to 20 or even 100 fires using the ICS 209 V3 and making sure that the Veers and MTBS match, because that was one of the hardest things that I had to figure out, was to find fires that were in this data set and in this data set and in this data set. And I'd also like to co-author with remote sensing specialists for further publication. So this is really interesting to me. This was some of the results that I had for the comparison. And the thing that I found the most interesting is, if you notice, the peak is around the same time. So it looks pretty plausible that they correlate in some way, but I'll have to do some further research to really get some detailed evidence about all of this. And it's the same thing here. You can see this peak right here, and for that matter, you can see the other peaks line up with those peaks. So the peak fire growth days may be associated with peak releases in fire radiative energy. The rate of spread and fire radiative energy may be correlated for most fires, from what I found out. The trapezoid rule and midpoint rule give similar results, off by less than 4%. And the fire type and detection gaps might produce outliers, such as East Troublesome and Watson Creek. Some of the next steps that I'll go further with would be comparing with DNBR as well. I did a little bit of that, but I did not get far enough on DNBR to be able to present that just yet. DNBR, as I said before, is the difference normalized burn ratio, and that's the change in near infrared to shortwave infrared reflectance pre to post burn. A proxy, and it's a proxy for burn severity at Landsat's 30-meter scale. Current status is I have manually downloaded the tiles for each fire, but I need to still properly calculate the DNBR. I found difficulties with cloud masking, matching the exact dates, and calculating the proper values. And I also need to refine the cloud in cloud shadow masks using CF mask, cross-validate DNBR hotspots with the other data sets, and build a statistical model comparing the FRE to the predicted DNBR. I'd like to acknowledge a few people. I'd like to thank Nate Hofford, Virginia Iglesias, and of course my mentor Nicole. She dealt with a lot with me, and I really, really, truly appreciate her for everything that she's done to help me. And really the rest of the Earth Lab, they were a really awesome group. They're an amazing lab, and they're doing really awesome research. And I'd like to thank everybody at Sears. I'd like to thank Alicia, Madison, and Carla at RECCS. They've been really, really amazing in helping all of us grow and become professionals. And lastly, I'd like to recognize the satellite data providers in this research: the VIIRS, ICS 209 Plus, MTBS, USFS. I didn't put it on here, but USGS, NASA, and NOAA. And I'd also like to state that OpenAI's ChatGPT was also used in this research. I have a QR code that will send you to, I also have like to thank NSF for the funding and the grant numbers right there. This leads to my website, and the website has a link to my GitHub, also to the references, and to the Earth Lab, and to my LinkedIn, and it's got all my information on it.